In question number 4, we have two magnitudes. F1 equals 9.6 newtons and F2 equals 3.2 newtons. They're asking us what third force will cause the object to be in equilibrium. So we drew a little graph, a representation right here, and we have the F2 going up is positive, it's going to be 3.2, and the F1 is going to be negative 9.6 newtons going to the left. To find the third force, it has to be to the opposite side where F1 and F2 is, because that's going to cause it to be in equilibrium. So we have this triangle right here and the angle theta inside. Now we add up both magnitudes F1 and F2, and we do a system of equations right here. So we're gonna add also the third force. I'm gonna label as F, and since we said it's gonna be the opposite as the two forces, the two magnitudes, it's gonna be plus 9.6 newtons and negative 3.2 newtons. So at equilibrium, that means that the sum of all these three forces is gonna add up to 0. Now, to find the magnitude, we just do square root of F1 squared plus F2 squared, which is the same as 9.6 squared plus 3.2 squared. And then we square the whole thing, and that's gonna give us approximately 10 newtons. Now to find the angle, we just use some trigonometry, and we use the values that we have. So we have the following value right here, the negative 3.2 newtons, and the positive right here, 9.6 newtons. So opposite side of theta divided by the adjacent is going to be the trigonometric function tangent. So on the calculator, we just plug in the inverse of the tangent, and in parentheses we put the 3.2 over 9.6. The negative value doesn't matter in this case, and that's going to give us an angle of 18.50. Now the 18.50 is not the angle that we're looking for. 18.50 is only theta, but since we have the first force, or the magnitude, originally we have going this way to the left, and the third force going downwards this way, we could say that this whole angle is 180. So to find not theta, let's call it alpha. To find alpha, we would have to subtract the angle theta that we found right here. Subtract 18.50 minus 180 to obtain alpha. In this case, we just subtract and we get 162 degrees. In the next problem, we have a plastic ball in a liquid that is acted upon by its weight and by a buoyant force. We know that the weight is 2.6 newtons, and that the buoyant force has a magnitude of 4.4 newtons, which is acting vertically upward. It says at a certain point the ball has a zero velocity, and at that exact moment the external force acting on the ball has an acceleration of 3 meters per second squared in the downward position. So the question is, find the external force and its direction. So we just drew a representation of what was written over here. So based on the Newton's law, the sum of all the forces equals mass by acceleration. We encounter the weight, which is going down, and the acceleration is going down as well. That makes the weight be positive. and then plus the external force what we're trying to find minus the buoyant force, which in this case is going upwards based on the equation, all equals ma. Therefore, we just do some algebra. We put in the values, we move everything to the right side so we can find the external force, and we end up with 2.60 newtons going in the downwards direction. We saw